In section 2, we are going to start talking about length. So first we're going to talk about line segments. So a line segment, or sometimes you'll see it referred to as just a segment, is a measurable part of a line that consists of 2 points, which we call endpoints, and all of the points between them. So what that means is you can take any part of a line, choose 2 points on that, and the distance between those 2 points is called a segment. So a segment with endpoints A and B can either be named as AB or BA. It doesn't matter the order in which you list it as long as you use your 2 endpoints. And then also when we're naming a line segment, instead of having the arrows at the end like we did with a line, we just have a single bar. And lastly, the length or distance of our segment AB is written as just AB. So when we talk about length, we just list the 2 endpoints. We don't use the bar over top. So let's talk about drawing segments. I highly recommend that if you don't have a ruler with you, you get one so you can be as exact when you draw your segment. So if I want to draw segment LM that is 42 millimeters long, if you grab a ruler, 42 millimeters, as long as you have if you have a ruler with centimeters on it, that'll work because 42 millimeters is 4.2 centimeters. So if you have a ruler and so I want to start my segment with L, and then if I go 4.2 centimeters to get M and then connect those points, we get LM. So this is segment LM, and if I want to describe its length, I write LM equals 42 millimeters. And lastly, we want to draw QR that is 5 centimeters long. So again, using a ruler, we start at point Q, 5 centimeters, draw a dot to get R, and then connect them between, and then I can say QR equals 5 centimeters. So it's a very important distinction that when we're talking about lengths of line segments, we don't include the bar over top. So the next definition we're going to talk about is betweenness of points. And that says point M is between points P and Q if and only if P, Q, and M are collinear and PM plus MQ equals PQ. So that tells us is the 3 points have to be on the same line, and then if I take my point that's between, that creates 2 segments, and add those 2 segments together, I should get the length of the entire segment. So we're going to use this in a few examples. So starting off, we want to find the length of LM. So using this, we know that LM plus MN is going to equal LN. And then we just plug in what we know. Well, we're trying to find LM, so we don't know that, but we do know that MN is 2.6 centimeters, and then we know the length of our entire segment LN is 4. To solve for LM, we're going to subtract 2.6. So we get that LM equals 1.4, and then because we are given units, we're going to include centimeters. Next, we want to find the length of XZ. So using our definition for our length, we have that XY plus YZ is going to equal XZ. XY is 4 inches, so we have 4 plus YZ is 2.5 inches. I don't like to write mixed numbers, so I'm going to write it as a decimal, so 2.5 equals XZ. So now we just add 4 and 2.5, so we get that XZ equals 6.5 or 6.5, and then our units, which are inches. And then our last example is to find the length of DE. So when we set up our equation, we have that DE plus EF is going to equal DF. DE is what we're trying to find, so we're going to leave that alone. And then EF is 2 3/4 inches. Just like the previous example, I'm going to write it as a decimal, so we get 2.75 equals DF, which has a length of 12 inches. So similar to the first example, we're going to subtract 2.75, and we get that DE equals 9.25, or 9 1/4, and then our units, which are inches. And that is the length of our segment. So our next example says, find x and st if t is between s and u, st equals 7x, su equals 45, and tu equals 5x minus 3. Anytime you're given a problem with this much information, it's always a good idea to draw a picture, which we already have for us. And part of it is already labeled. We have ut is 5x minus 3. We have st is 7x. And the last thing we just have to label is the fact that su is 45. I can now use the definition of betweenness of points to set up an equation. So we know 5x minus 3, which is the length of ut, plus st, which is 7x, is going to equal the length of su, which is 45. So my first step is going to be to find x, because if I know x, I can find the length of st. So combining like terms here, 5x plus 7x is going to give a 12x minus 3 equals 45. And we're going to add 3 to both sides, so we get that 12x equals 48. Then we're going to divide by 12. So we're going to get that x equals 4. So we have solved for one part of the problem. But remember, this says to also find the length of st. So now that I know x, and I know that st is 7x, I can do st equals 7 times 4, which gives us the st equals 28. And we don't have units on this problem, so it's fine that you don't include them in your final answer. So we had to solve for two things. We know x equals 4 and st is 28. So our last example says find y and pq if p is between q and r, pq equals 2y, qr equals 3y plus 1, and pr equals 21. Notice how it says draw a picture, because if you don't draw a picture, it can sometimes be very hard to figure out how to set up your equation. So I'm going to draw my points, Q and R, and now I know P is between them. I don't know where, so I'm just going to draw point P somewhere between Q and R. Then I'm going to start labeling what I know. PQ is 2y, QR, which is my entire segment, is 3y plus 1, and PR is 21. So now that I have my picture and everything labeled, it's going to be easier to solve for y. So using the betweenness of points definition, I know that PQ, which is 2y, plus PR, which is 21, is going to equal the length of QR, which is 3y plus 1. Now I want to work on getting my variables on the same side. So I'm going to subtract 2y from both sides. So we get 21 equals y plus 1. Then I'm going to subtract 1 from both sides, so we get y equals 20. But we're not done with the problem, because we also have to find the length of PQ. So we know that PQ is 2y, so we do 2 times 20, and we get that PQ has a length of 40. And now that I have PQ, I can look to see if my image was drawn correctly, and PQ is longer than PR, and it looks like that in my figure, but without knowing for sure, there was no way for me to know when I initially drew it. So next we want to talk about congruent segments. So when we talk about the definition, we have two segments having the same measure are congruent. So if I look at my example here, we have that xy equals 2 centimeters, and we have PQ equals 2 centimeters. So because they both have the same length of 2 centimeters, I can say that segment XY is congruent to segment PQ. And this symbol right here represents congruent. So in our first example, we want to name all of the congruent segments found in the kite. So we're looking for anything that has the same length. So first I can see I have BC and CD both with length 10 inches. So we can say BC is congruent to DC. So that's 1. Next, if we look, we have 14.4 here, and we also have another 14.4. So I can also say that AD is congruent to AB. That's the second set of congruent segments. Thirdly, I have 8 inch from B to E and also from D to E. So I can have a third statement that says BE is congruent to DE. And the only two segments we haven't talked about so far are CE and AE, which don't have the same length. So we are done with our congruent segments in our kite. So next we want to find the measurement of RS. So we have that the whole segment RT is 4.8, and then we have these little tick marks right here and here. These tick marks are another way of indicating that two segments are congruent. So what that tells me is that RS is congruent to ST. So when I write my statement, instead of saying RS plus ST equals RT, I can actually say RS plus RS equals RT, since they have the same length. That tells me that 2RS equals RT, which we know is 4.8, and I can divide by 2, and we get that RS equals 2.4 centimeters. And in this case, we are given units for our segment, so I do want to include them in my final answer. So in our third example, we're going to use the figures to determine whether each pair of segments is congruent. So let's start with AB and CD. So AB is 3 centimeters and CD is 3 centimeters. So they have the same length, which means they are congruent. So I can say AB is congruent to CD. And this is called a congruent statement. Next, we want to look at WZ and XY. Now, I know XY is 4 inches, but I don't know what the length of WZ is. But if we look, we have double tick marks, which that is another indicator that the lengths are the same. So even though we aren't explicitly given that WZ is 4 inches, the tick marks tell us they are. So I can say WZ is congruent to XY. Next we have HO, which is 7 millimeters, and HT, which is 9 millimeters. Now 7 and 9 are not the same length, which means my two segments are not congruent. So one way you can say that is HO, and then when you do your congruent symbol, you can put a slash through the equal sign. That stands for not. So I have HO is not congruent to HT. You can also write it out as well if you would like. You can just put not congruent instead of the congruent statement. And then our last example, we want to look at MH and TH. So MH is right here, and here is TH. Now, we aren't given the length of TH. We know MH is 7 feet, we know AM is 15 feet, we know AT is 15 feet. But we don't know the length of TH. And because we don't have the perimeter either to help us solve for that, we don't know for sure that MH and TH are congruent segments. We don't have a tick mark that tells us, like in example B, so even though we were giving one length, we can't infer that that's the same without those tick marks. So there's not enough information here to know for sure that those two segments are congruent. So unless we're given more information, for right now, MH is not congruent to TH. It could be slightly longer, it could be slightly shorter. You can't assume based on a picture that just because two things look the same length that they are, because these pictures are not drawn to scale. So hopefully this is a good introduction to lengths for you guys, and let me know if you have any questions.